Okay, hello, and yes, methods in calculus for further maths, A level. Find the exact mean value of some function of x which is equal to sine x cos x over cos 2x plus 2 over the interval of 0 and pi over 2 for 4 marks. Exam question, and it's sensible to try to rewrite the sine x cos x. So if we're considering sine x cos x, I'm going to and I better put that down, considering, what's a bit too thick there, considering, yeah, let's make it a bit, considering the integral of sine x cos x over cos, the double angle, cos 2x plus 2 dx. Now, if we compensate straight away, that will give us a half times the integral, and we can make that sine 2x over cos 2x plus 2 dx. Now, that helps us a lot because now we can use substitution. I can say let u, I can say let u equal cos 2x plus 2. Cos of 2x plus 2. And therefore du will be equal to minus, and better move that out of the way, minus 2 sine 2x dx. Minus 2 sine of 2x dx. Therefore, I've got, therefore I can use a half times the integral of sine 2x over cos 2x plus 2, cos of 2x plus 2 dx equal to, and now here's the substitution, a half times a half will be minus a quarter, half times minus a half times a half is minus a quarter, times the integral of 1 over u du. And we'd have that equal to minus a quarter, then log u, or natural log of u plus c. And now substitute back in the value of u, which is cos 2x plus 2. That will give me equal to minus a quarter natural log of the modulus of cos 2x plus 2 plus c. And the mean value then of some function of f given the parameters of 0 and pi over 2. So I need to just write mean value of some function of x on, and here we have it, 0 and pi over 2, that's a comma, 0 and pi over 2, will give us, let's do it, we'll take out, that will give us 2 over pi, and with the limit, integral of the limits, pi over 2 and 0 of sine x cos x over cos 2x plus 2 over the cos of 2x plus 2 dx. And what will that give us? Well, we need to use what we found. We found that minus 1/4 log of cos 2 modulus of cos 2x plus 2, and then we put in our limits. But we've got 2 pi outside, so we got 2 over pi outside, and we have our boundaries, which is minus 1/4, and it was natural log of cos 2x plus 2, cos 2x plus 2, and with limits of pi over 2 and 0. And we'll end up with, once you do that, you'll find that that will give you the answer of log 3 over 2 pi. And yeah, you can use a calculator to do that, and that's what you should end up with. Okay, then we have another question for methods in calculus, an interesting one. On the next page, let me go to the next page, page number 2. Let's go. Just checking that. Okay, it's all in real time. Show that, yes, and this is where we have improper integrals with, of course, the limits to find the limits to infinity, and convergent and divergent series. So let's have a look at this. Show that 8x minus 12 divided by 2x squared plus 3 times x plus 1, the integral of with limits infinity and 0 dx is equal to the log of k, where k is a rational number to be found, and 7 marks for this one. Now there's some skill sets here that you need to be familiar with. The first one is to select the correct form of partial fractions, because this is a partial fractions example where you have 8, and I'll write it out, 8x minus 12 over of course 2x squared. We write it out the question, 2x squared plus 3 multiplied by x plus 1, and now the select the correct form of the partial fractions. We've got to do ax plus b, because we've got a square term in our first bracket, over 2x squared plus 3, and then plus c over x plus 1. So that's selecting the correct form of the partial fraction, and then you got to find the value of the 3 constants. We now equate 8x minus 12, of course, 8x minus 12, which is equal to ax plus b times the other, which is x plus 1, and plus c, of course, multiplied by 2x squared plus 3. And that will give you, of course, if we look at x equals minus 1, looking at this bit here, we have x is equal to minus 1, which will imply that c will be equal to minus 4. Yes, if x is minus 1, we've got c will equal 2 times minus 1 all squared C will be equal to, yes, that's right, C will be equal to -4. Yeah. And therefore x will be, when x is 0, x is equal to 0, implies that b will be equal to 0 as well. And when x equals 1, implies that a is equal to 8. So we have our values there of x given x equals 1, x equals 0, and x equals -1, x equals 0, and x equals 1. So we can get values of a, b, and c. Comparing coefficients will also give you, what will that give you? If you compared coefficients, that's another method. You could say, well, a plus 2c is equal to 0. You can say a plus, just quickly do that to show you that there are other methods. A plus 2c is equal to 0. And a plus b is equal to 8. A plus b is equal to 8. And you can have b plus 3c. B plus 3c will be equal to -12. That's another way of doing it, and then you'll get your values for a, b, and c, which will be the same values that we attained before. So a will be equal to 8, a will be equal to 8, b will be equal to 0, and c will be equal to -4. Now, going back to the integration of 8x, so we've got 8x over 2x squared plus 3, because that's the value of a, 2x squared plus 3, minus, substitute these values in, 4 over x plus 1, because that's the value of c. Put that in brackets, dx, which will give us 2 natural log of 2x squared plus 3, minus 4 log, natural log, x plus 1. So we can extend this to 2 log of 2x squared plus 3, 2x squared plus 3, minus 4 log x plus 1, which is equal to, and because of our division rule, natural log of, we'll have to put it 2x squared plus 3, because it's division, because we're subtracting, 2x squared plus 3 and all squared over x plus 1 to the power of 4. And yeah, that's good to go. Yeah, that's correct. 2 times the natural log. Yep. Now, with the limits, now you need to write out here your limits. So you put limit where x tends towards infinity, and yep, we have the log of 2x squared plus 3 all squared, and 2x squared plus 3 all squared over x plus 1 to the power of 4. And yep, which is equal to the log of 4. The log of 4, which is equal to the log of 4. The log of 4. Yeah, you could do it another way, limits to infinity, and you could have 2 natural log times 2x squared plus 3 over x plus 1 all squared, which is equal to 2 log 2. So the integral, this implies that it's either or. This implies that the integral of with the sum to infinity and 0, or with boundaries of infinity to 0, not sum to infinity and 0, boundary conditions of infinity and 0, of 8x minus 12 over 2x squared plus 3 times x plus 1 dx is equal to the log of 4 over 9. 4 over 9. And that's 7 marks.